In this video, I'm going to show you a couple proofs that go with some of our theorems that we learned in 11.4. And I'm actually going to do number 6 before number 5 because we're going to actually use this theorem in the proof for 11.4.4. So let's start here. I'm going to do this one a little bit more informally, but just to essentially show why this theorem works. Okay, so what I'm going to do first is I'm actually going to draw in a radius. Okay, so this is a radius and this is a radius. So because of that, right, this is congruent to this. So essentially what I have formed is I have formed a isosceles triangle. So we know that an isosceles triangle has the base angles are congruent. So I'm going to say let angle A equal x. Okay, so that means that then angle B also equals x because triangle ADB is isosceles. So I'm kind of doing a little more of a paragraph proof here, you guys. Okay, so, and sorry, I should probably put the m's in front here, the measure of angle B. Okay, so we're going to call these both x. Okay, now I'm going to label this other angle up here. This is our central angle, right? And we know that the central angle is equal to this. So I'm going to call this one y. So I'm going to say let angle, measure of angle, CDA equal y. Just so I don't have to label it with 3 letters every single time. Okay, then the measure of arc, CA, equals y as well. And we know that that's our central angle because it is the central angle of, I should say this, it is the intercepted arc of a central angle. So we know that central angles and their intercepted arcs are equal. So that means this one is also y degrees, right? So this arc and this angle are equivalent, okay? All right, so we want to show that x is half of whatever y is. Okay, so what we know is now I have this triangle here, and y and this angle right here have to add to 180 because they are a linear pair. So I'm going to say that this has to be 180 minus y, this angle right here. So I'm going to say measure of angle ADB equals 180 minus y because it is a linear pair with y. Okay, so now we know that all 3 angles in a triangle have to add to 180. So we have 2x plus 180 minus y has to equal 180 by triangle sum theorem. Okay, so if I simplify this a little bit, I could subtract 180 from both sides. And I have now, if I do that, 2x minus y equals 0. I use the subtraction POE there. And I'm going to add y to the other side. So now I have 2x equals y. And that was the addition POE. And now, if I want to get x equals half of y, we're really close. I'm just going to divide both sides by 2. So if I divide both these by 2, I get x equals 1/2 y when I use my division POE. So we just showed that the angle, when it is vertex on the circle, that it's equal to half of its intercepted arc. Okay, so we just proved the inscribed angles theorem, which says when the vertex is on the circle, that angle is half of its intercepted arc. Okay, Now, we're going to use that theorem in this one. And this one I'm going to go ahead and do a 2-column proof, you guys, just a little more formal. See if I can fit it all here. Okay, so I'm going to start with the inscribed angle theorem. So I'm going to try and show that angle A plus angle C equals 180. Okay, so we know that angle A is half of its intercepted arc. So its intercepted arc is BCD. And that is this theorem, the inscribed angle theorem. Okay, now I'm just going to multiply both sides by 2 just to rewrite it a little differently. Okay, so that's just my multiplication POE. And that'll just make it a little easier for me to talk about later. Then I also know, so if this, let's see if I can use, so from here, that's the intercepted arc, that has to equal 2 times whatever angle A is, right? Based on that. So angle A, this is double that. So then this other half, so BAD, is 360 minus this, right? Because that whole thing has to add to a circle. So the measure of arc BAD is equal to 360 minus this arc, BCD. Okay, and that is just, we know that all circles sum to 360. Okay, so I'm going to substitute in this guy, measure of, sorry, not angle, measure of arc, BAD, is 360 minus measure of 2 times angle A. And that's just substituting this up here, so substitution. Okay, all right, so now angle C is equal to half of this arc, angle BAD, which is this, 360 minus 2 times the measure of angle A. So this is the inscribed angles theorem and kind of substitution at the same time. All right, so if I distribute my 1/2, I get angle C equals 180 minus measure of angle A. So that is just the distributive property. So if angle C is equal to 180 minus angle A, that means that angle A and C are supplementary. And that's just the definition of supplementary. All right, so we, draw my line there, separate those. So we just showed that angle C and A, opposite angles in a quadrilateral when it's inscribed, must add to 180. Okay, those are the 2 proofs for 11.4.